Okay, 6.4, the first day, I'm just going to give you some new formulas to look at, and I'll show you how you can use them to your advantage. Tomorrow we'll talk about identities in 6.4, and also applications like non-unit circle stuff. But the first day is actually pretty simple. There is a typo in this lesson though, so I got to remember to mention it. Okay. Okay, I have a new question. How would you find sine of 75 degrees? What would most people probably do? If I said find sine 75, what would you probably do? Get out your calculator, right? So what is it about sine 75 that makes it a calculator problem? This is not a special angle. It's not sine 30, it's not sine 45, right? So you would probably just grab your calculator and punch it in, make sure you're in degrees mode, and you would get 0.9659 approximately, okay? So, are there problems like these that are not really special angles that can still be done without a calculator? That's an interesting question. Like, you suppose there might be certain types of non-special angles that we could do without a calculator? The answer is yes. The fact that this is 30 plus 45 is interesting to me. Because 30 degrees is a special angle and 45 is a special angle, so I wonder if there's a way to just kind of split this up into two angles that we know, and then maybe we can find the sine without a calculator. Does that make sense? Okay, so here's what maybe a naive student would do. A naive student would say, okay, I'm going to take sine 75, and I'm going to break it up into sine of 30 plus 45. I'm going to try to think of 75 like that. And then I'm just going to go sine 30 plus sine 45, which is a half, plus root 2 over 2. Looks like I already have a common denominator. Final answer. Now, does any of this student's work seem a little fishy? Does any of this work seem a little bit fishy? I think so. I don't really understand how the student felt that they had the right to do this. Sine 30 plus sine 45. Did that bother anyone else when I wrote that? That kind of thing should bother you. I mean, would you solve a problem, if I give you a problem like this, would you go root 4 plus root 9 is 5? Would you do that? No, you know this is rad 13. You know you can't distribute a radical. Can't do that, right? Well, we can't distribute the sine either. So this student is naive, but I like that they're thinking because there is actually a way to use sine 30 and sine 45 to get the answer. But before we do that, can someone tell me why this cannot be right? Besides the fact that the student illegally distributed a function symbol into an argument. Yes?
Is it not in the domain of...
Okay, you're on the right track. What were you going to say?
Oh, well, it's not equal to 0.9659.
That's true.
Small.
That's true. In fact, this is 1 plus approximately 0.4 over 2. This is approximately 1.2. But can someone tell me why that is not acceptable? Yeah, Jason. Yeah, sine cannot be greater than 1. See the problem with this? Sine cannot be any greater than 1, no more than a probability can be greater than 1. Okay? So we have to understand that there's something wrong with the work, but the way of thinking is clever. The student is clever in some sense. At least they saw that 75 was 30 plus 45. Here's how the student should actually do it. They should follow one of these 6 formulas. I'm going to show you all 6, and then I'll rewind and let you write them down, okay? We have a formula for adding 2 angles and finding the cosine. We have a formula for subtracting the angles and finding the cosine. We have 2 formulas for sine. One is for sine adding 2 angles, and one is for sine subtracting 2 angles. And we have one for tangent, adding 2 angles, and one for tangent, subtracting 2 angles. Okay? Let me go back and show you the formula so you can copy them down. Don't spend too long copying, because we don't have a lot of time. But just jot them down. They're also in the book. The first one is called the cosine sum formula. The second one is called the cosine difference formula. Great names for these. Very creative. And then I'll show you sine and tangent in a moment when we need them. Now when I give you a pair of new formulas like that, do you have to memorize both?
Yes. Or you can memorize one and then just negative.
Yeah, if you've been copying these formulas, you realize that when there's a plus in the parentheses on the left, there's a minus on the right. See the opposite signs right there? So as long as you know that, you don't really need to memorize the rule below it. The second rule is the same thing with a minus here and a plus here. So just understand that memorize the first one's really good enough. Apply it. Use your common sense to get the second one. You know what I mean? So anyway, let's take a look at this problem down here. It says find the exact value of cosine of 105. This is kind of similar to what we were saying a minute ago with the sine 75, right? We know that 105 is not a special angle. It's not a multiple of 45. It's not a multiple of 30. So it's not on the unit circle, at least not at one of the markings. So what we have to do is be clever. Is there a way to write 105 as a sum of two special angles? 45 and 60, right. So what we're going to start off with today is we're going to go, let's take cos 105 and split it into cos 60 plus 45, like that. And this is sort of like alpha and beta. You can think of them as A and B. Okay, A and B if you like. And since we're finding the cosine of a sum of two things, we'll just follow this little prescription up here. It's like cooking. Anyone can cook if you have the recipe and the ingredients. Okay? The only way to mess it up is if you get distracted or do something wrong. But it's all right there. It says we're going to be doing cos 60, cos 45, minus sine 60, sine 45. Let's put that all together and see what we get. So this would go cos, minus sine, sine. That's the formula. And all of this stuff we can grab from the unit circle. This is a half, and this is root 2 over 2. And this is rad 3 over 2, and this is root 2 over 2. So in the end, we get root 2 minus root 6 all over 4. Not quite obvious, you know. It's not like you would think to do that. But this is how it works. You do cos minus sine to get a cosine of a sum. Okay? Now let's say another student comes along and says, oh, I wasn't even thinking about 60 and 45. I was thinking of 135 minus 30. 135 minus 30, that's also 105, right? So let's see if that student's work would work as well. They're looking at cos 105 as cosine of the difference between 135 and 30. So this student is looking at 105 as a difference of two things. They're going to have to use this first formula up here, with a minus here and a plus here. So it's going to be cos plus sine. Let's see if it works for them. So they're going to be using cos plus sine. That's just what their brain did. They weren't thinking about 45 and 60 at all. There's no reason why this shouldn't work. This is negative root 2 over 2. And this is root 3 over 2. And this is root 2 over 2. And this is a half. And looks a little different right now, but when combined, this is still negative rad 6 plus rad 2 all over 4. Same thing as root 2 minus root 6 over 4. It's the same answer because the student is using a difference, but following the difference formula. Same answer. Okay, now if you have a TID9 and you type cos 105, it will actually spit this out. It'll look just like this on the screen, but if you type cos 104, it'll give you a decimal. As because it doesn't know what to do with the 104. It can't combine special angles to get 104 very conveniently anyway.
Can you,
Okay?
can you combine, like, say, more than two?
You can. You can actually get cos of, like, we'll talk more about some other rules later, but you can actually find cos of other things too
Yeah, but
that
like,
aren't just a sum or difference.
could you do, well, like, three terms, though, like, say,
Cos of
30,
30 plus 15, or
30 plus,
I understand your question. I think what you're saying is, could we extend this and do like a cosine of alpha plus beta plus gamma formula? Create our new formula like this? Yeah, we certainly could. But if you're going to add special angles together, the chances are you're going to start getting special angles. Like if you add 30 and 60,
yeah,
that's a special angle. If you add 45 and 60, that's not a special angle, but if you tack on another 30, it is. See what I mean? So it wouldn't be very useful. But you could extend this into 3 if you'd like. It'd just be a mess. Okay, good question. Very good question. Let's go on. Let's talk about sine. There's a typo here. Let me fix it real quick. This should be a minus sign. So with sine, the signs are consistent. With sine, the signs are consistent. We have a plus here and a plus here. Minus here goes with minus here. The formulas are a little mismatched. It's a sine alpha cos beta and a cos alpha sine beta. But at least the positive goes with the positive and the negative goes with the negative. That's nice. So let's try the same thing with, this would be a sine sum, this is a sine difference. Let's try using these guys to solve the problem down below. So I would like to know what pi over 12 is in degrees, because that might help me a little bit to understand how I would approach this. Okay, so first thing I'm going to do is change pi over 12 into degrees. So just multiply by 180, divide by pi. Turns out it's 15 degrees. Okay, so this is just saying find sine of 15. Okay, so we want to find sine of 15 degrees. Probably want to use 45 minus 30 on this. That's like the most logical thing to do. But you could be creative if you wish. I'm just going to use 45 minus 30. This is a sine difference, so I have to use this green formula here that I'm circling up above. So it's going to go like this. Sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. And this gives me root 2 over 2. And this gives me root 3 over 2. And this gives me root 2 over 2. And this gives me a half. So this time I get an answer quite similar to last time. This time it's root 6 minus root 2 all over 4. And after you've done a few of these, you realize, wow, these answers all kind of look the same. That is true. They often do look quite similar. The hardest part is memorizing the formula. Plugging in the numbers is easy. You guys wouldn't be in this class if you weren't good at plugging numbers into formulas, because you never would have passed, your previous classes, right? Algebra 2, honors, geometry honors, tons of formulas, right? Volume of this, volume of that, plug the numbers in. This lesson is kind of that way. Okay?
is there a multiplication and division formulas?
Sine of alpha times beta, sine of alpha divided by beta, that sort of thing? Yeah, sure. But remember, multiplication is just serial addition, right? That's all it is. It's like you do sine of, if you want to think of, again though, I'm going to say it again, once you start multiplying special angles, you start getting special angles. You do like 30 times 15, and you're dealing with, whatever, 450, that's already a special angle, so it's not very useful in our case. Let's look at tangent. Tangent's the ugliest of the batch. But honestly, you don't really need a tangent because sine over cosine is tangent. So you could actually just find sine and cosine of 105 and then divide to get tan if you wanted to. But these are the formulas, and you have to have them memorized at least so you can quote them to me on the test. So if I ask you what is the tan sum formula, you should be able to write it. And so let's just look at this real quick. It goes basically tan plus tan over 1 minus tan tan. See that? So the top is a sum, the bottom is 1 minus a product. It's really not very hard. If you want to help your brain remember it better, you could put parentheses around this to remind you that there's multiplication downstairs. Upstairs is just adding. Okay? Again, you only need to memorize the blue one up here because the green one, that thing is just the same thing with the signs flip-flopped. Okay? So let's go ahead and try this problem down here. First thing I'd like to know is 13 pi over 12. How many degrees is that? Since I'm too lazy to think in radians. So I'll just multiply by 180 over pi. And this cleans up to give me 195. I did it earlier, okay? It's 195. So this question is ultimately just wanting tan of 195. And I'm going to try and think of that as, what two angles might I choose? There's more than one answer to this question. What would you guys choose?
225 minus 36.
225 minus 30, we could do that. What would you say? 135 and 60, that works. Or even 150 and 45, that works too. It's totally up to you what you want to pick. I'm going to go with the 135 and the 60, but it really doesn't make any difference, as long as the sum is 195. I probably would be more inclined to work with addition, so I probably wouldn't do the 225 minus 30. But so this is actually a really easy formula. It goes like this. It goes tan plus tan on top. It's ugly, but it's not hard. And then on the bottom, 1 minus tan times tan. Okay? All right. So simplifying this, tan of 135 is just negative 1. Tan of 60 is just rad 3. And those show up on the bottom also as a 1 minus a product. So you can just write this as root 3 minus 1 over root 3 plus 1. And don't leave your answer like this. We should rationalize, right, as a courtesy. So we multiply by the conjugate of the bottom. We don't want radicals in the denominator. This is going to give you 4 minus 2 rad 3, and this is going to give you 2. So your answer is 2 minus rad 3. 2 minus rad 3. And then I'm going to show you one more real quick. Just real quick, just takes 2 seconds. This question looks hard and looks different, but it's really not. This is just sine of 130 minus 10 in disguise. This looks like sine alpha cos beta minus cos alpha sine beta. It just looks like that. So I think what they're doing is they're writing the question kind of backwards. I'm interpreting this to mean the sine of the difference between 130 and 120. Okay. This question is ultimately then just asking what is sine 120, and that's just basically rad 3 over 2. So give those a try. That's how you do number 21, for example, on tonight's homework.